I will share my screen. Let's see, share, and that should be the one. Yes, and we started it. The idea for it came with actually a lot of CG members. There was a big meeting we all had in 2015, and actually several people in the audience were there. And then in 2017, we really had the formal partnership in January of that year between the Minnesota Supercomputing Institute and the Food and Ag College at the University of Minnesota. And so what is GEMS about? Well, really it's about actionable informatics. Well, GEMS is kind of we're trying to drive innovation in the food and ag sector through data science, and while at the same time fostering public-private partnerships. And we now have expanded to not just the platform, but actually 5 services. And I'm going to briefly go through those and again, explain where ontologies come into play in some of these. So just briefly, I'm going to say a one-liner about each, and then we're going to go into a little bit more detail. The platform, many of you may be familiar with, is really it's a secure place that is not subject to the Freedom of Information Act in the United States, in the sense that all data, agricultural data placed in the platform is private, non-public by state statutes, and that data from anywhere placed into the platform. And it's a place where people can convene, share data, clean that data, and do analyses right on the platform. But additionally, we have a sensing platform, which is actually a lot of ground sensors that folks can deploy, sometimes for custom purposes, to make measurements and effectively beam those measurements back to a central cloud platform. Likewise, Exchange is we realized that a lot of people wanted to use the same set of data sets, and we wanted them to be interoperable. And these should be standardized in some way, rather than pulling data from various places and having to do a whole lot of cleaning on them. Learning was born under the notion that capacity building is a critical need everywhere in developing nations, but also in companies in various places. People just don't have the data science skills that they need, and that's what we're trying to provide. And finally, GEM Solutions is really just expert consulting that we provide as needed. So a little bit more about the platform. For those of you who have tried it in the past, it has a new user interface that makes it a lot easier to navigate. We think it's actually a lot of, it's quite easy to use. And again, it's a convening place, as I mentioned, for folks to do their work interactively with others. We promote FAIR principles. And one of the things we do to promote FAIR principles is we effectively force them, when they register data products, to enter certain metadata information that is required. This is from the FGDC as well as the Dublin Core, but see the ... dots mean that there's other stuff that they have to fill out. But when they make their data discoverable to others, they are required to put into red fields here. And we give them prompts for the type of information that should go in there, but they, of course, have to enter their own information. We also have other optional tabs that they could, additional spatiotemporal data or different components of GEMS that they could add to enrich that data even more. And the purpose really of this adding more metadata is, one, to understand what you did, but two, to make the data findable or discoverable. And that is on the platform. When you're searching for data products, you could type words in the title or any words that appear anywhere within the metadata. You could lasso a region, like in this case, Africa, and say, I wanted stuff. Or you could pick a restriction of the years, 2007 and 2013, who sponsored the data, so what team uploaded it, filtered by data, file types. These are all the kinds of things that could shrink your list of things that you find or discover on the platform. And in terms of the actual data itself, we assist users in, if they have a CSV file or a tab delimited file, we assist them in being able to match each of the column headers to an appropriate ontology term. This is in progress. This view is what we had for a while, and we're actually in the background. We're making a whole bunch of upgrades to this, which I will show you on one of the later slides. But currently, it matches to ontologies. It makes an attempted fuzzy match given the name to some existing ontologies in here with ranked order. And then if the person enters something, they may choose from any of several different possibilities that may come up here. As I said, this is a work in progress because in my mind, it had never been up to a standard that I wanted. Plus, we had some great conversations with Marie-Angelique, and we're finally making some of those implementations, but they're not reflected in the site yet. The platform itself has been really important for some public-private research that's been going on internationally. A lot of this is sponsored for the Foundation for Food and Agriculture Research, who has made the platform kind of their central place to work in their convening groups. So far, there's 5 that are officially using and 2 that are onboarding right now. And each of these consortia are composed of several companies and often a public member as well. For example, this one's Wisconsin, as well as 3 different companies. And likewise, that's pretty much the case of all of them. So overall, so far, there are 20 companies that are interacting with public interests through the platform. And they're exchanging their data and actually convening on this platform. I want to switch gears for a moment to tell you about GEM sensing, because it's pretty cool. We've been doing this for about 3.5 years now. And really what it is designing not just weather stations, like local weather stations, but actually sensors for all sorts of things. Like I'll show you later, there's sensors to detect carbon dioxide, sensors to detect oxygen and things of that sort to see whether the lawns or grass underneath the snow and ice whether they're becoming deprived of important gases, and that's leading to winter kill. So these sensors are actually being built by our own electrical engineers. I should say they're designed by them, and they're actually being built now by accredited commercial electronics fabricator. And that's important because originally we had graduate students trying to assemble them, and it just, the QA/QC just was not up to snuff. And now these things are really, really good. They've got a secure back-end logging system, and that's actually critical. This logging system is not only is all data QA/QC'd that comes off that logging system, but you can plug and play into these exterior ports here other systems as well. So we've hooked up Campbell Scientific Campbell Scientific instruments onto this central data logger, and then streamed up the data in the same QA/QC'd manner as other data. And all of the things that we do here are doing their best to adhere to an accepted ontology in the field called a semantic sensor network ontology. And that's kind of critical too, to keeping the data fairly standardized. So these have been deployed to each of our research outreach centers across Minnesota. And you can see them, they look like weather stations because that's what they are. Additionally, we have several of them out in Malawi. 54 were deployed in 2022, as well as a whole bunch that are in US, Canada, and Norway. So at this point, honestly, they've been over 2,200 devices by the end of this month. We'll be on 3 continents, supporting projects in irrigation, pesticide drift measurements, mesonets, as well as the turf winter kill that I mentioned. So pretty exciting development. All that data is beamed every 15 minutes to the cloud. It can be accessed on the platform or just on your laptop. It's a pretty cool instrument. GEMS Exchange is something I want you to become familiar with, or just to at least let you know what it is. So GEMS Exchange is actually a whole lot of data streams that we've standardized. Most of them are both spatial, temporal in nature. And we have created a grid, a harmonized grid that basically starts out at 36 kilometers, goes down to 9 kilometers, goes down to 3 kilometers, 1 kilometer, then 100 meter, 10 meter, down to 1 meter. So we have functions on that grid can allow us to aggregate data up or disaggregate down with certain assumptions. And so you can move data to different resolutions, as well as have everything projected onto the same coordinate reference system. And that's really, really critical, because lots of times when you get geospatial data, you have to be a GIS expert in order to deal with. And with this grid, you don't have to be an expert. You can grab things at the same, always on the same projection and at the same resolution. So The GEMS weather, of course, is the most important thing. We tested several different options for weather out there of people that were providing historic weather, for example. And we tested those against ground truth data from our Genomes to Fields project and determined what the best outcome of that was. And so that's what we provide, with the most accurate weather that we have seen out there, as well as predicted future forecasts up to 16 days out potentially. But in addition to weather, we have things like soils, we have watersheds, water quality across lakes, and all sorts of things like crop calendar, elevation maps, land cover, market access, and pest risk profiles. So all provided in the same coordinate system. Finally, we'll talk about our second to final. We'll talk about capacity building. I just want to say that we offer usually spring and fall a bunch of different courses that are remotely accessible. And we've actually had a whole bunch of folks from our partners at Stellenbosch University attend our courses, as well as folks in Saskatchewan. And these courses try to meet a sweet spot of that intermediate level. So folks who want to learn R itself, we're just partnering with Stellenbosch on that, but our focus is actually more on, do you want to do spatial integration or spatial, advanced spatial concepts within R? We offer those courses, and we're also going to offer Python equivalents as well coming in the spring. So finally, there's always the option for GEM solutions, which, hey, we have over 20 experts in a range of different fields. So if you have a solution, if you have a problem that needs a custom solution, you can work with us, and then we can work with you on that. These are some of the organizations that have taken us up on that. So let's talk a little bit more about, under the hood, which ontologies for the platform are we moving to? And I say moving to because they're not reflected on the current website, because we're actually literally in advanced. I thought we might be done by this talk, but we're not quite there yet. It's probably going to be early in 2023, like January, February. But still, again, in conferring with Marie-Angelique, we've got a large list of ontologies that are in there. So crop ontology, and there's also a precedence of order of which we should accept. Now these I would love to tweak a little bit with Marie again, because she gave us from a smaller subset of the list some rankings of which one. If I have terms that seem like they're similar, now in principle, many of these should be orthogonal and they should not have overlaps between them. But in the cases where some of them are not, within your alliance, and so in the cases where there are multiple terms, it'd be good to go with a more reliable one over another one. So anyway, these are the current order that we're doing. Again, I'd love to have input from folks in the community, like yourselves. But additionally, within crop ontology, now these were selected because these are the things that are important to us in Minnesota at the moment, plus our direct collaborators in other countries. So these are the ones that we currently are including from crop ontology. A little bit about how do we do matching to ontologies. It's not rocket science. It's basically what you all would do. It's basically, we custom parse the ontologies, load them into Apache, Jana, and Fuseki. And we do Sparkle queries, again, custom queries to basically create Sparkle output that's converted into JSON. And so all sorts of information from these ontologies are loaded into our Elasticsearch engine. And any user queries from the columns that you saw that are matched, they're basically directly searched through Elasticsearch against those terms, so they can get a fuzzy matching to terms that are identical or similar to those that they entered. So that hopefully you can pick out the ontologies. Now, we haven't done yet is the ranking of, say, if I come with multiple terms, pick them from this ontology or that. That's actually being implemented, but that's the basic idea behind the scenes. And this is all of the things that we're currently working on. And maybe if you have suggestions for additional things we could, while we're in this development cycle, maybe that now would be a good time. Originally, we only allowed you to match one ontological term to a column, but that doesn't make any sense. Sometimes a particular column actually matches different aspects of it match, particularly tagging a column with Unix from a standard units ontology. That's critical, because just because I could have, yield, for example, in the usual American terms in bushels per acre, or it could be kilograms per hectare, for example. And it's important to actually at least flag that, what those units are. One big thing that's bothered me from the beginning of when we've had this is people can't actually see the descriptions without actually going to, Ontobee or somewhere where they can check the descriptions. And finally, we're loading those in to allow someone to mouse over and see what the description of the suggested term is, so they can say, oh yeah, that's a match, or oh no, that's not a match at all. Applying weights to ontologies so that you could fuzzy match to some and higher precedence over others is what we're applying. And also reconfiguring the platform infrastructure so that right now it's a lot of work, or it had been a lot of work for us to add a new ontology, or even say a sub-ontology like a new crop under crop ontology. But with the new infrastructure that's already designed and being laid out, that should be pretty easy, quick, easy pipeline to parse the things and add one. So, and then we will add additional ontologies as needed. So, yeah, that's it for the talk section. I would love to hear a discussion on various points.
Thank you.
Elizabeth, I think you're muted.
Oh, sorry. Yeah. So I was thanking Kevin for the very nice presentation. Really very interesting to see the new development behind GEMS. I have some questions, but first, perhaps I would like to see if any of our colleagues would like to ask a question. You can raise your hand. You can write questions in the chat, of course. We have several Marie-Angelique because Marie shared her personal link. So in case you are not Marie-Angelique and you want to talk, just please say who you are. Any question immediately from our attendees?
Yeah, I have a question.
Yeah, Marie, go ahead.
Camera, even if it's the mess. Yeah. So I was Kevin. Hi. So nice presentation. Thank you. I mean, it's good to see the updates and then the improvement over time. I mean, that's great. So my question is, if is the platform open to anyone to use, or is it not?
So the platform is open for anyone to use for the level of seeing what's in there that's either in GEMS open or shared with everyone, and but it does require a subscription if you want to actually do analysis on the platform, or you want to register your own products. But those subscription costs have come way down. Once upon a time, we convinced folks that forget about investments that we made. It's really just we just trying to recover just the maintenance and actual keep going forward. And so the costs have come significantly down. So.
Okay, thank you. And then on the ontology piece, just to let you know, if you need anything, so feel free to contact me if you need any guidance on what ontology to use. Also, I mean a lot of ontology improved over time as well, like particularly the agronomy ontology and the environment ontology. So I'd be curious to see how they can be used for the project that you have.
That's great. You can bet I'm going to contact.
Yeah. And on this topic, I wanted also to say that you listed a large range of crops that are used and present in crop ontology. So in case your partners need new traits, additional traits, of course, you know that they can contact us. You already put us in contact with PepsiCo for oats and potatoes. So, but we can help if traits are missing.
We also put FAR in contact with you for lettuce, and hopefully that's
lettuce. Yeah, true. So that's a very good collaboration, I think. My question is, you are mapping the crop ontology at the trait level, not at the variable level. We are proposing the trait, but also the variable if the files your partner are uploading have precise values with the indication of the method used. You are not using that level in our ontology.
When you say the variable level, could you give me an example?
For example, for us, the trait will be potato surface color, but this can be observed with a scale 0 to 10, or can be assessed in laboratory method with some index.
Yep.
So it means that when you retrieve the values, you need to know that the values were not measured the same way. It's coming from different origin. So that's
exactly. And that's precisely why we wanted, when they're matching a column, which actually represents both, we thought it was very limiting that we only allowed one ontology term to be matched. We would like both, the trait as well as the variable to be matched each time. So
okay, that would be certainly
and units. Mm-hmm.
And Abby, sorry, I saw you had your hand raised. So if you want to open your mic.
Hi, hi, Rajabeth. Am I audible?
Yes, you are. Hey, Abby.
Nice, Abby.
Hi, Kevin. How are you? After
Good.
a long.
Yeah, I know it's been a while.
Yeah, it was a quite coincidence. Actually, I and Kevin were talking on some aspect, and then we got. So it's very impressive. I think I participated. I came to Minnesota, I think 5 years before, probably, and then we had, and then like we experimented Jupyter book at that time, and did some kind of analysis. So my question is, first question is regarding open access and shared databases. What you have, will you have any? Because I think they are not public databases even now. Like they are the shared databases within the GEMS community. But like if you want to make them really open access, like people, like they will not be able to coming in the search engines, or direct link will not be there.
Yeah, so as we speak, so there's two developments going on underneath, and these are things that we've wanted for ages. It's just that we've been short-staffed with software developers for a long time. But there's two things that are literally going on. One is creating DOIs. We've had actually a space from our libraries for over 2 years, and we still have not implemented being able to create a data object identifier for all those GEMS open products, which has hampered our efforts to try to make the open part. And that means that those landing pages will be outside. You don't even have to log in, and that will make it so much easier for folks when we finally have that. But Tom Prather has been given the specs. He's starting on it, literally starting on it now. And we hope by February-ish. And then separately, Trevor Wemblom is working on the ontology effort, and he's already, Trevor's made a lot more progress on that because he started a lot earlier than Tom. Tom worked on the whole new.
Yeah, because when we are talking about fair, fair principles, and then first F has to be really versatile. So
Yes.
like it's fair as of now in the GEMS ecosystem, but I think it will make good, like catchy for us, because I could see, I'm very much impressed. Like now GEMS is actually developing into kind of ecosystem, in which several things are available, and like these kind of linkages. And I haven't, if I missed your slides, like could I see you talked about the computational infrastructure available and its scalability? Like I missed that?
Oh, you
Like
didn't miss it. I didn't mention it. So computational infrastructure at the moment, what GEMS is on is it's on its own, basically in its cloud within the Supercomputing Institute. So it's got all the security of it, but it's on its own machine. We're using something called Open On Demand to help us scale to the supercomputers that if jobs need to be dispatched to the supercomputer, they could be. That's also a development. We have one person that actually is working with the San Diego Supercomputing Institute because they have the same issue of how to do that, and he's going to bring that knowledge to help us to scale our computation onto the supercomputer. But you're right. Right now we can't.
Yeah, because I'll be very much interested if you have some future presentation somewhere else, or because I know you kept this presentation for this group, where you are going to talk about using computational resources available with GEMS, storing data, analyzing, and scalability part of and storage and sharing. That's where we all are heading into now. We are looking at several solutions, And I think GEMS is one of the potential partner in that aspect. So if you have some other presentation sometime in future somewhere else, maybe when you do the San Diego Supercomputing Institution, etc.,
Mhm.
I'll be happy to like hear you at that time. Thank you
Okay.
very much.
Okay,
Very
that's useful.
exciting
Yep.
presentation. Very happy to see the progress made in the last couple of years.
Yeah, well, thank you
Congratulations,
so much.
actually. Yeah.